Okay, so I told you we would tell you how to find the sum of an infinite geometric series. So here's the formula, and I'm just going to give you the formula. I'm not going to derive it. You put S. Notice there's no subscript because it's the S of an infinite number of terms. Okay, the sum of an infinite number of terms. And it turns out the formula is one of my favorites. It's pretty small. A sub 1 over 1 minus R. Now, just a cautionary note, if you're putting this in a calculator, you would need to put this in parentheses, okay? All right, so let's see what we've got. Find the sum, if it exists, for the following. Okay, so first you have to decide, is this an infinite geometric series? Okay, so if you look at 9 over 10, okay, so like if we're thinking it's geometric, that'd be the ratio. And then this is 8 over 9, or yeah. Okay, no, this is not geometric. So we're done. Okay, now let's look here. Well, let's assume it's geometric. 99.44 divided by 248.6. I don't know. So let me do this on a calculator. 99.44 divided by 248.6. And I get 0.4. Okay, now I have to check it though, so let's try these two. 39.776 divided by 99.44. Hey, it turned out to be the same thing. So this was 39.776 divided by 99.44. And that also equals 0.4. So that's enough information to say this is geometric. The ratio, is it less than 1 and greater than -1? Yes. 0.4 is between 1 and -1. Okay, so then now I need the formula. S equals A sub 1 over 1 minus R. And A sub 1 was 248.6. divided by 1 minus 0.4. And we'll go ahead and just practice putting this in the calculator. So it's a smaller formula. So 248.6 divided by parenthesis 1 minus 0.4, which I know you could do the 1 minus 0.4, but just on the calculator. So the sum is equal to, now we're not going to round off, 4.14.33. And you could show the repeating that way, or you could write it with the bar, with a little bar over it to say the 3 repeats. Okay, so great, that was fun. Let's go to the next one. All right, this is in the form of a geometric sequence, right? You've got a term, you've got a ratio, and it's to the n minus 1. Your variable is k, but that's okay. That's okay. Anyway, it's in that form. So it is geometric. I mean, you can find more terms, but it's in the right form for a geometric sequence. So because it's summation, it's a infinite geometric series. Okay, so yes, it's a geometric series. Okay, great. Now, what is the first term? Well, the first term is going to be this, 4,374. What's the ratio going to be? See, you're following like this little form you have for a geometric sequence. Well, the ratio is -1/3. So is that between -1 and 1? You know, is it? Yes. Okay, so this is an infinite geometric series. We can use the formula. So here comes the formula. S equals A sub 1 over 1 minus R. Well, my A sub 1 is 4,374, and it's going to be 1 minus -1/3. Okay, now if I don't want to put that in a calculator, and I don't really want to, I can say it's 4,374 over, think of it as 3/3 plus 1/3. You can do it that way. And that's going to be 4,374 over 4/3. So invert and multiply. That's going to be 4,374 times 3 over 4. It was going to look like a decimal if I wasn't careful. Okay. So let's just do this on a calculator. 4,374 times 3 divided by 4, and let's see what we get. I get 3,000, so the sum is equal to 3,280.5. Okay, great. And it looks like we have one more. So it looks like it's in the form of a geometric sequence. It's a little bit different because it doesn't have the k minus 1, it just has k. But it looks like every time we're going to be multiplying by 4/3, right? Well, let's do a little more work here. Let's put in 1. So 1/9 times 4/3. What's that? 20, oh, not 20. 4 over 27. Okay, so that's the first term. Then what's the second term going to be? Well, it's going to be 1/9 times 4/3 squared. So that's going to be 16 over 81. You can think about 9 times 9. Okay, what would the third term be? Well, the third term is going to be 1/9 times 4/3 cubed, or 64 over, what's 27 times 9? It's 243, I think. Yeah, 243. Okay, and then it keeps going. I'm not going to do any more. I want to see what the ratio is doing. I want to see if it's geometric. So the ratio would be 16 over 81 divided by 4 over 27, or 16 over 81 times 27 over 4. So 4 goes into 16 4 times, 27 goes into 81 3 times, so you're getting 4/3. Now, you probably suspected that. We said we think it's geometric and it looks like the ratio is going to be 4/3, but we're just double checking. So now take these two terms, just to double check. 64 over 243 divided by 16 over 81, which is going to be 64 over 243 times 81 over 16. And that's going to be 4/3. Okay, so it is geometric. It is geometric. An infinite geometric series. It's infinite because it's going to infinity. Okay, but is the r is 4/3, is r between 1 and -1? No. So it's not defined. So it's getting bigger and bigger. All right, there we go.